Trane package heat pump or American Standard package heat pump. Customers' complaints. System not keeping up, not heating very well. This unit was manufactured 2010. Supply air temp going into the home, registering about 80 degrees Fahrenheit. Return air temp. We'll give it a minute here so it can settle down. It's a downshot installation, no elbow or stand, used a curb. All the ductwork comes out from the bottom of the system. Defrost board in here has a light using fault codes. Flashing more than 4 times per second indicates we have a problem somewhere in the system. This is a variable speed Trane system, so it has a fan control center board here for the variable speed that can be adjusted for different airflows from 350 to 450 CFM, enhanced mode, or comfort R they call it, to improve the efficiency of the system. No heat strips on this system. This is where the heat strips would go if there were heat strips down in this compartment here. So when it did go through a defrost, it would energize the heat strips. So sometimes you had a system with backup heat, low charge, or other problems, you might not notice it as quickly. This is the compressor of the system right here. Compressor compartment. These are gauges on. It's an R410 system. These are the temp compressors that we're reading at this time. 43 psi on the low side, 230 on the high side. Indication, most likely low freon. Very hard to charge. Heat pump in the heating mode. Really the only way for sure to charge it. So we have to evaluate the system, see what's going on. Down here on the compressor, this is a suction line of the compressor where the tag is right here. In here, we have oil residue here. A little oil on my finger. You can see oil on the pipe here. It's dirt. Mainly dirt, not real oily, but a lot of dirt collecting. Down in here, this is what they call a low pressure switch on this line here. This is a suction line coming down here. And again, right in here, we have some dirt. A lot of times when the dirt builds up like this and it's kind of moist, indication of possibly a little bit of oil residue with it. Kind of checking a line like this up here, we see we have no dirt on here. The system just shut down right now because it's been running a while. There's no dust or dirt up here. A little collection down here, maybe there's a slow leak somewhere in this area. But the unit had shut down now because I had been running it before I checked the temperatures and kind of just see how it runs. And what it did is the defrost board, it's on a demand defrost board, and it sensed that the system was icing up on the outdoor coil where we saw that frost. So now it's came back on and it switched itself into air conditioning mode here to thaw out the outdoor coil. That's the defrost board right there, that light flashing. When it goes into defrost up here, it switches it in air conditioning. It drops this outdoor motor out of the rotation so it doesn't work. That way it builds a higher pressure up here on the outdoor here to thaw out the outdoor coil a little bit quicker. You can see where we originally looked down in here, there's a stripper down in there. It's a little hard to see, but we can see down in here we have no frost on it right now. So now it's going through a defrost because it was sensing it wasn't performing correctly due to the temperature of the coils and line temperatures and the sensors was not indicating proper operation. It'll go through this defrost until the sensors get to the calibration that they need in order to switch it back into heating mode, and then she'll start heating again. So the system was short cycling with the customer maintaining the house about 72 degrees. We'd never get hotter than that. So it was producing some heat. Return air temperature in the house was 70 right there. 68, 70 degrees is what it was inside the house. When it was in the heating mode, we were putting out 81 degrees. So we had a about 11 degree temperature split, which is not acceptable. So so what we do now is we know the system has a leak, or it should not have leaked the Freon out. The Freon had to go somewhere. Could have been an error to a technician checking charge before, leaking out of the valve core or something like that. But because this is the first time we're here at the property, so it's really hard to eliminate, you know, problem where maybe a technician problem or a problem with the unit. It's hard to tell. So virtually what we're going to do, the customer needs heat. We're in the heating time of the year. We know that we have to do something with this system here. So what we're going to do is we're going to charge it up to pretty close to the correct operating pressures and temperatures. Okay, that way we get a full charge in the system, or real close to it, so that the system will be under the proper amount of pressure. And then we're going to kind of do a soap bubble leak search through the system here. If we can find out anywhere that the system is leaking. That noise you heard right there was the reversing valve, and the reversing valve just switched back into the actually de-energized to switch into the heating mode, so it'll start heating again. And if you notice, it started heating again, so that come on up over here, we got the fan motor going again. Okay, so we're back in the heating mode. So that's kind of where we're at for starters here. This is just a typical service call. So now we're gonna pause this here and let me get set up here, and we'll continue this here in a minute. Okay, continuing back to try to get it kind of up to the approximate charge that needs to be in the heating. We're going to take a return air temperature dry bulb for the heating check coming in at 73.6. That's what we got for dry bulb coming in from inside. Trane gives you a chart down here for the heating check. The charts gives you kind of an idea or a guideline to go by. Is what it does here. So it kind of gives you the head pressure you're looking at over here on the side, the discharge pressure. Gives you an outdoor temperature down here on the bottom. Then it gives you what you call pressure curves. In here it kind of tells you a dry bulb return air temperature, so you can get close to there. You got 80, 70, 60, we're at 73 inside. So then it tells you down here what curves to use, how the curves you know, works. That's right there how the curves work. It says from top to bottom, so 80 top, 70, 60 down like that. So we're going to say we got 73. We're in the middle here. Up here we're in the middle of this top curve right here. We're up around 73 in this area. I know this is hard to see, but and we're down here outdoor temperature. We're right now about 50 degrees. We're in this area right in here. So maybe we're about in the middle here, 75, somewhere in that area. So we're looking over here. We go across here, maybe our head pressure should be in the area of, I don't know, 350, somewhere in that area. Again, the only way to really correctly charge it is in the heating mode is to weigh the charge in. But this gets us real close, so that's what we're going to do right now. We're going to go see. I put a little Freon in earlier just so I didn't have to waste time on the video here. We come back over here, we look at the gauges, what we got going on here, and virtually we got 350 head pressure right about there. So that looks pretty good. Looks like we're pretty close there. So we'll kind of just take a temperature split over on the back so we can see where we were. We originally had about 70 degrees and 81 before we added some Freon to the system, before we could do the leak check. So we're gonna come back over here. We're heating up inside because we're running it pretty good now, but we got about 74 inside. Take this out, put it in the supply duct over here. Boom, boom. And we'll give that a minute here to heat up and see where we're at. So that's kind of where we're doing now. It's just a typical service call. The unit only 6 years old. A lot of people think the unit should last longer than that, but it all depends what the unit's been through, who's worked on it, different things like that. So we're going to see where we're at. Give it a little time here, get that temperature split so we can see if we're close to the temperature reading that we want. Yesterday we cleaned out our coil already. We checked the indoor coil. We know we're good with all that. So we got a leak in the system somewhere. We've lost Freon. Freon just doesn't dissipate like or get used up like oil or gas in a car. It means we got a problem. So once we see where the split is here, we'll pause this video and I'll try to get some panels off here so we can kind of go through the process of doing a leak search on the system. It's kind of what takes involved when you go check a unit. It's very hard to tell the customer exactly what they're going to expect until you kind of go through the system. Some repairs are simple, some are easy. This could be a technician error, or simply they put the gauges on or took the gauges off and valve core stuck a little bit, didn't put a cap on tight on the valve cores, like these plastic caps they have down here. Come from the factory. Most units all got plastic caps on right here that goes on these valve core connections up here. Sometimes take the gauges on and off, the valve core can leak or something like that, and it's always been nice metal caps on. That way, if you charge a system up because the first time you've been at the property and you suspect it was leaking out of the cap, once you leave here now you got good valve cores on, caps on, so you don't have to, you know, second guess yourself. So see what supply air we got coming out now. Now we got 102 degrees supply air coming out. We got almost a 30 degree split, 27 degree split. That's pretty good. It's good enough at this time because again it's a heating mode. We don't mess around with it too much. So let me pause this and we'll get some panels off here and we'll see if we can find out where the leak came from. So talk to you soon. Okay, this here we're going to do a leak search of the system. I'm going to have to do this in a few segments because it's really hard to do it and hold my camera, but you can see all these little capillary lines right in there. They're little feeder lines. Although little feeder lines, a lot of times they'll rub. You get a slow leak out of one of those areas there. Most likely when you're looking for a leak, there's usually oil. Like I showed you earlier, the indication of the oil on the suction line there. So you're looking for oil, residue, and just to see where, if you can find a leak. The system's off right now, so it's just stabilized at pressure. Probably 150, 75 psi, both sides there. And you just go in and out with this electronic leak detector, and it will pick up a leak if there is a leak. It's tedious. That's why leak search is not the least expensive things to do. And then you still got to figure out if you can repair a leak when it's done. So just go through everything and check it out. I did a lot of this before I put my camera on here, the recorder, because this is a hard area to get to. So yeah, so this is what we're gonna do here. Have to climb in the unit to do it. It's a little tough there. Gotta go through all the parts. A lot of times in the heating mode, this coil here, where we're looking at here, this is a high pressure coil. That's an indoor coil. The return air ducts down in here is a downshot unit. But this is a cooling coil and a heating coil. Heat pump, it's a high pressure coil. This coil, 350 psi going through there. Cooling mode, 125, 145 psi going through that coil. So on heat pumps, a lot of times you're looking for the leak in the highest pressure at the time. That side of the system there. Anyways, that's kind of where we're at with that. So this system does have a hard start kit on it. Don't put a hard start kit on it right there. That's a hard start kit for the compressor right there. Compressor run cap up there. So again, we're going to go through and see if we can come up with a leak here. Been working on this for about 30 minutes. I haven't come up with anything. I haven't done any soap bubbles yet or anything. So again, we just kind of go through everything and see what we can come up with. Haven't come up with anything. It's kind of happens. Takes time. Sometimes you got to fire the system up, and sometimes this indoor coil will only leak at a certain pressure. Maybe when it's running at 300 psi. We came here today and we had 230 psi when we first started, so it leaks anywhere between 230 to 350 if there is a leak in this indoor coil. So that's what we're looking for. So we might have to pump the pressure up to kind of find the leak. There's a little residue in the pan here. This is, I mean, it's a little bit oily. If you look at your finger right here, my finger here, where's my finger? Look at my finger there. I mean, some would say that's just dust or moisture. There's no moisture here in the heating mode in this indoor coil. This is a high pressure coil, and so there is a small residue in the bottom of this pan. That's a very good indication that it could be leaking in this indoor coil under a higher pressure. So that's kind of what we're leaning towards here. You have to have been doing this a while to kind of isolate where you think the leak's coming and be pretty positive about it, because you don't want to fix a system or change a part for a customer and be wrong. So again, this is the first time we're out to this property, so we handle this a little bit different. That's why I did charge it up to try to look for the leak first to get it at a higher pressure. That way, if I don't really come up with a positive solution today, I can come back and recheck this in a couple of weeks and see where my pressures are and see where I'm at. It gives me a good idea of the leaking rate I'm dealing with here. So that's kind of where we're at. That blower has got a lot of stuff on it, on the scroll cage there. It's hard to see, but could be because high static, maybe in air moving slow, running a real cold, moist indoor section in there can build up with that. So a lot of growth, we call it. Anyways, so let me pause this a second here. We'll pick back up where we left off the leaking. I've searched all this coil. Like I said, it looks like a little residue in the pan there, but it's really hard to clarify that. Searched all up inside the outdoor compartment up there, TXV, all the distributor lines, didn't find anything up there. So I'll back down here to where the compressor is and the oil that I saw on this line, the residue here and the dust here. Again, it should just wipe off. It shouldn't be an oily condition there. So anyways, but I just go back and I'm checking this. I pulled this plastic cap off that I talked about earlier. I'm coming over here. I just kind of check this here like this. Just slowly check it. And we get a hit right there. That's a hit right there. It's a pretty solid hit right there. Pretty solid hit right there. And like I said, being the first time at this property here, and it had plastic caps on, which is kind of a no-no with our company. We put solid caps on everything. We would go ahead and I think what I do, you can change that valve core right there. I got a valve core remover to change it, so we can change that valve core and put a new one in there. But again, I just double check it there. Up there. I feel pretty comfortable with that, if you can hear the right there. And this is at, again, we're checking this right now here at static pressure, it's called. System's off, it's just, and it's a static pressure. Again, the static pressure of the system right now is, again, this takes time, so I'm sorry about this, but the static pressure is We're looking at about 215. So we're back to checking this here. Sorry, my phone ran out of data storage. It's crazy. But again, we're at 218, 160 there. I showed you earlier in the video leaking out of the valve core there. First time we've been to the property here. Can't find any leak anywhere else. So we got to charge it up where she needs to be. Gonna put caps on there, solid caps on there, and then we're gonna run it there. The customer got on a service agreement with us. They're aware there could be other problems with the system, but this way we'll run it out and then we come back out before summer and check it again, see where we're at. So that's kind of the sum of this call right here. So that's how it took. It took about an hour and a half to go through all this stuff and do it, but that's why you should have your system checked and serviced, because you never know. And if it continued to run like this here in the condition it was, it could have taken a compressor out. Definitely cause you high electric bills. Cause lots of other problems. So anyways, I'm gonna put the system back together there and move on to my next one. Thanks for your time.